Hello. So here we are. Hello and welcome. So I finished up the problem that we were working on yesterday. I took a look at the problem again, and I realized that the problem is a lot easier than I realized, and the problem is a lot easier than I had realized, and I think I've got the right solution now. So I'm basically just going to look to code it up. So let's go take a look at that problem. And so here we are, unique substrings and wraparound string from yesterday. I'll just reread it again quickly here. We define the string S to be the infinite wraparound string of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So S will look like this. So you see it sort of just keeps looping infinitely, this word. Given a string P, return the number of unique non-empty substrings of P that are present in S. I think that's missing a word. Return the number of P that are present of S. Am I reading this incorrectly, or is this just poor grammar? Given a string P, return the number of unique non-empty substrings of P that are present in S. I think I'm missing some words here. But basically the solution goes like this. What I had realized. Thought about it some more later today. So one thing that's useful to do when you're dealing with programming problems is break the problem, take the problem and make it like smaller, so to speak, like reduce the complexity of the problem. So right now we have ABC all the way to XYZ, right? And that repeats. We actually could just think of it like ABCDE, right? And the example that I used in my mind to sort out a reasonable solution was actually, wait, what was that? Hold on a second. What was that? I think I just hit a button and it gave me that noise. Yeah. I'm hoping nothing I don't want to show on screen is nothing that I don't want to show on screen is nothing that I don't want to show on screen is showing because of that noise. So okay, here we are. So we have A, B, C, D, E, right? 3 letters starting with A, 3 letters starting with B, 3 letters starting with C, 3 letters starting with D wraps back around to A, and then 3 letters starting with E wraps back around to AB. And you notice if you continue from E back to A, then the 3 letters starting ABC, you end up with the same three characters looping over and over, right? And so the reason why I wanted to use this example is because you could consider a string ABC, BCD, CDE, DEA, EAB, right? And then, oh, I'm sorry. Actually, I didn't really explain what the like inputs and outputs are supposed to be. So for P, CAC, the unique substrings are going to be C and A, and AC doesn't work though because C doesn't follow A. So you'll see an A somewhere in here, you'll see a C somewhere in here, but you won't see a CAC, you won't see an AC, you won't see a CA. So there's only 2, and so the result is 2. For ZAB, which is very interesting, ZAB you can see it, right? A follows Z, B follows A, and you can get basically all of the substrings of ZAB are going to be present. So Z, all the substrings of size 1, Z, A, and B, substrings of size 2, ZA, AB, and then finally the substring of size 3, ZAB. So you get 6 for this one. The easier subcase, I guess, that I thought of was something like this, and I realized, okay, basically for each substring, there's a starting character and then a length, and that starting character and length fully defines that substring, because all the characters in the substring have to follow a very clear pattern. They have to be alphabetical and then also with a loop around. So Z follows alphabetical where in alphabetical order where Z also follows A. Or A follows Z rather. A comes after Z. Z comes before A. So that actually means that given any character and a length, you know exactly what that string has to be in order to be a substring of this infinite looping of characters of the alphabet. So interesting. What that means, though, so what I came up with, that I realized, is that actually you could consider a situation where basically you want to find the maximum for each character, the maximum length of that string. And what this is going to do is that if you have for each character the maximum length of that string where each character follows, in other words, the maximum possible substring, each character follows that order. What happens is you could reconsider that there would be A, for instance, for ABC, where we know the maximum is 3. If AB, and you have ABC. Each of these different substrings, these are all going to be substrings, and they're all, because they start with the same character, but they have differing lengths. We all know that they're all different from each other. We also know that we only need the maximum length to know that all of those are going to be present. Similarly, B, BC, and BCD, all of these substrings are going to be different from each other because they all start with a different character from A, what we just saw, and they're different from each other because they have different lengths, right? And they have to happen to also be all of the possible substrings that could start with B, right? So they're also complete. CD, CDE, and then finally D, DE, DEA, and then E, EA, EAB. Okay. So now we say, okay, well, as it turns out, all of these strings are present here. From this string, all of these substrings are present in that construct, that looping construct. So the deal is we can loop through all of our characters A, B, C, D, and E, and we can just check what is the longest sequence, knowing that if we have a positive number for any particular character, the next number, like so if you have A and you have A and 3, you know that B has got to be at least 2, right? Because if for A to have 3, must have B to have 2, BC. So ABC would have BC in there. And then, so there's that aspect also. So first you could just create a map of all the characters and say, okay, here's the longest sequence that we found for each character, and then loop over it again. What you've got in your sort of character map, you can then also check that if you were to sort of continue through from a particular character, that the following characters are registered as at least as much as they could be, as they should be. Once you've done that, as it turns out, you could just add these together, the numbers, because these are all different from each other, and basically ABC, A and 3 implies all of the other ones above, and BCD, B3 implies B and BC as well, and same thing, CDE implies CD, CD and C, and so on. And so you just add them straight across, and you're done. So actually, this is like a really straightforward question in some sense. So let me try to put that together. So yeah, this consecutive lengths, basically what you're going to do is for each character, right? Yeah, from a particular character, starting position, starting character. So I kind of have this code already that sort of does that counting the longest sequence that sort of moves in alphabetical order, and then you start the next sequence and you just sort of continue that way. So we don't need this anymore, this code. And then this is kind of, we don't need any of that anymore as well. So we can say for int I equals 0, I is less than 26, plus I. We're going to say, so basically we could do it this way. Initially, it's going to be consecutive lengths of 0. And we're going to say we go to I, 2, or I guess 1 rather. We're going to say consecutive, I could spell, length, oh wow, oof. Lengths of I is going to be equal to, or we'll say current, it's better than initial, current, let's say current value. Current value is going to be the maximum, so the largest of the two, of its current value, consecutive lengths of I, and current. And then we're going to decrement current. Now, something to note here, we kind of want to compare these two values. So let's just do, can we do this? I don't know if this works. I don't know how to do this. I want to do a reference to this array position. If you do like int 26, right? It's actually a vector, right? It's a vector position reference. I mean, it might be easier just to use pointers. I'm going to do it this way. Can I do this? It's not the vector reference, it's actually the array access reference. Can you do that? Actually, that would be a pointer. That would be a pointer. That's funny. The address. I just want a reference, but well, can we do this? Vector int. Yeah, that's okay. Maybe we'll just use pointers then. Yeah. Not pointers, iterators. Yeah, maybe it's better to use iterators then. Consecutive lengths begin +1. Pointer is not equal to consecutive lengths end. I want a plus pointer. And I guess this is kind of a long, just put it on another line here. Okay, well, I guess you could move this over too, but we'll leave it for now. Maybe we should do that, actually, that's better. It's kind of ugly if we don't put it on the same line. There we go, okay. All right, how are we doing? So, yeah. So, current consecutive lengths, pointer, begin +1, it's not at the end, increment the pointer, and we want to say if this pointer value is we actually want to start off at -1. We'll do it that way. So this pointer value is greater than current value. Then we want to update this pointer value to the current value. Excuse me, the other way around. If it's this pointer value is less than the current value, we want to update this pointer value to this current value. And then we're going to decrement the current value. If it's the other way around, actually, really yeah, it should be like this. We're going to set the current equal to the pointer value and then decrement the current. That's really what we want to do. So regardless of whatever the value is of that position, we want to take on that value of the value of it and then decrement it, which, yeah, so yes. Okay, yeah, we'll do it that way. Okay, that's fine. That's there. All right. Okay. I'm just thinking if there's like a cleaner way of doing this, but it really doesn't matter. Doesn't need to be clean at all. So sure that the longest sequence beginning at any particular character is sure that the longest sequence beginning at any particular character. Sure, the longest sequence beginning at a particular character is recorded properly recorded appropriately. Okay, now we just accumulate. I'm gonna rename this. This is too much to type. I keep typing it wrong too. Just call it lengths. This is like not very satisfying to type this whole thing out each time. Okay, I think this is all we need now. Let's see. Compiler error, nice. We also need algorithms, right? See how we do. Wrong. Nice. Oh no. Really? No. No. What do we have before? A, B, C, B, C, D, C, D, E, D, E, F, E, E, A, E, A, B. Alright, first things first, let's check. Does this work at least on the test case that I was trying before? It did, it does, okay. But this doesn't work on the other ones, no? Really? That's surprising to me. That's surprising to me. Works here. Oh, I know why. I know what the issue is. I know what the issue is. Yeah, I got it. I know what the problem is. You need to actually make more than one loop around. You need to make more than one loop around. That's why. You can't just go straight down. Yeah. Have to actually make it all the way back. You gotta go A to Z, and then back to Z again. So you start at A, you go down to Z, and then you actually do this again. Do this twice, this loop. That's why. Yeah, okay. And then you do the same thing again. So current becomes, this pointer gets set back to the beginning again, which is length stop begin. So at the very end, we get pointing to Z, decrement current, and now we set this back to the beginning when we increment. And then we just do this again. I believe. How about that? Okay, right. It doesn't. Yeah, I'll explain. It basically, when you're dealing with a situation where something towards the bottom actually has the most stuff in it, and actually you should actually have it loop back around to update the other parts. That's why. I think that's why this failed. So this one should fail. Would fail on the other example. But should work now, I guess. I hope. Yeah. Okay. Good. Okay. Got it. All right. Alrighty. I think I understood. Yeah. So actually, even in my mind, I got it wrong. I had the right idea, but it was still incorrect because of how do we do? How long does it take to code up? It took me 20 minutes. I had the answer, and it took me 20 minutes to code it. Can you imagine? Well, it took me 20 minutes to explain it and then code it. But really good question. Give this a +1. I don't know. I can't think of any other test cases. This is probably it for me as far as the test cases. Let's go for it. Hey, sweet. Can we get 100%? 1, 2, 3. One more time. 1, 2, 3. Oh man. All right, one more. Oh, we got 100% on the memory, but we're not 100% on the speed. It's probably about as fast as I could do it. Ooh, slower now. Man, we're so close. We would need to speed this loop up a little bit somehow. I don't know if there's a way. I'd have to move something here. Oh man, we're so close. One more. No. All right. Well, one more time. One more time. Padding my submission rate here. It's not what I'm trying to do, but it's happening because I'm trying to get the zero milliseconds here. Roll is 0 milliseconds. All right, we're pretty good though. I think yeah, we would just need to speed this up a little bit more. I think by what could we do? I wonder if this accumulates to make things slower. I don't think so. Part of me thinks if I get rid of this if here and tack this on at the bottom, it'll be faster. Right, so if we do that, what does that look like? That would be C equals P of X. It's sort of how I would normally write it. I wanted to make it more concise, but if I want to get those last 4 milliseconds, then basically this loop goes in at the end. Excuse me. And we have this previous character C. No matter what, if this is all the same, this isn't equal to the size anymore. This could just be C. That should have been C before too. Didn't realize that. And then we say A, previous start character minus A, previous start position X, L. We don't really need L, do we? L, it would be X in this case is P dot size. Length of A is, get a phone call. L, length of A. Oh, we don't need to update these. Does this still work correctly? It does. Are we sure? Still slow. Still slow. We're so close. So close. What can I do to speed this up? Oh man. Oh, it's so close. Come on. One more, please. Oh man. What can we do to make this 100%? What can we do? No. I think I gotta remove some of the stuff inside this loop. You know what you gotta do? I know what I gotta do. I know what I gotta do. If L is less than lengths of A, or L is greater than lengths of A, lengths of A equals L. I think that's what I gotta do. I think that's the problem. I think that's the problem. No! So close. It's so close. Alright, how about this one? Is this still correct? Looks like it's still correct. Is it faster? Not much faster. Man, I'm trying. I'm trying to find something. Just trying to shave off just a few milliseconds. Nope. Nope. Come on, man. There's got to be something. Can we do a standard array? How about this? Compiler error. I think this is initialized at 0. Oh, nope, it's not. It's not initialized at 0. Hold on. Whoops. Wait, what did I do? Okay, hold on. Okay. Fill, right? That's what we want. Actually, we could do this. How about that? Alright, let's go for it. Hey! Hey-oh! Hey-oh! Got there! Hey! 100%. How you like that? How you like that? Alright, how long did it take? Took an extra 7 minutes to optimize. Let's actually go back to what we had originally. And then with the accumulate, that was like a much cleaner code. Alright, was this what we had before? There we go, okay. So it's a little slower because we're initializing a vector. That's why it's a little bit slower. However, if we used, by the way, this should have been C. By the way, could make this an array. That's a little bit faster than using a vector for, in this case, in this instance. Vectors have a little bit more weight to them. Okay, alright. Looks like all those changes that we made were, alright, maybe not. Oh man. Maybe we do need to make all those changes. What do we have just a moment ago? Maybe I should have deleted the changes. Oh, alright, that's fine. I don't know which one of my changes was I guess all of them to get combined made a difference. Okay, or it's just random. Or it's just random. See if it still works if we do this. Man, oh man. Man, oh man. A little bit of loop unrolling here. Okay. I don't know, maybe it was just randomly that we just happened to roll 0 milliseconds. I mean, we got there, but barely. I guess none of those changes really mattered. They don't really matter that much, do they? I don't think so. Not really. No, didn't matter at all. It really didn't matter. Oh. Okay. Alright. So we just kind of randomly got 0. I mean, okay. Okay. That's fine. Alright, we'll go back to what we had then. Yeah. What does this do? Does this work? Alright. Yeah, I prefer this. I think this is better. It's a little bit cleaner. 4 milliseconds. We got 0 milliseconds somewhere in there. Randomly rolled that. Alright, we can stop here. That's enough. So yeah, thank you for watching. Talk to you soon. Have a good rest of your day. Yeah, I'll go to the next problem, I guess. Yeah, take care. Bye.